Now, before I show you how to run a multiple regression analysis in SPSS, I wanted you to know how the analysis is calculated. It's important to note that I will not have you actually calculate a multiple regression because, as you can see, it is a complex calculation. I just wanted you to have a basic idea of what the math is doing. So, in multiple regression, you calculate the coefficients b hat for each independent variable separately. Each calculation takes into account variation in all of the independent variables, just in different ways based on which independent variable you are focusing on. So in calculating b hat for the first independent variable x1, you take into account variations in the first independent variable x1 and the second independent variable x2. This is similar to calculating b hat for the second independent variable. You also calculate the a hat separately. This calculation is similar to the calculation for a hat in the bivariate regression. And you calculate the significance test for each b hat and a hat separately. The significance tests in multiple regression are the same as in bivariate regression, where you conduct a t-test for each b hat and a hat to determine if they are different from 0. Now I'm going to show you how to run a multiple regression in SPSS. Consider the following hypotheses. Hypothesis 1. As the average GNP of a country increases, the amount of resources that country devotes to defense spending increases. Hypothesis 2. Countries involved in a conflict will spend more on defense than countries not involved in a conflict. In both cases, defense spending is the dependent variable. It is measured in thousands of dollars. And we have two independent variables, GNP and conflict. GNP is measured in dollars, and conflict is measured as 0 or 1. 0 means a country is not involved in a conflict. 1 means a country is involved in a conflict. Running a multiple regression in SPSS is the same as running a bivariate regression in SPSS, except with more than one independent variable. So you do analyze regression linear, you put the appropriate dependent variable in the dependent variable box, and you put all of the appropriate independent variables in the independent variable box. Then you click OK. This is what the output should look like. The first row tells you the statistics associated with the constant a hat. The second row tells you the statistics associated with the first independent variable. In this case, it is GNP. And the third row tells you the statistics associated with the second independent variable. In this case, it is conflict. The B column tells you the values of A hat and B hat for each independent variable. And the SIG column tells you the results of the significance test for A hat and each B hat. So the first thing you should do after running your multiple regression is write out the equation. Recall that the equation is dependent variable hat equals b hat 1 times the first independent variable plus b hat 2 times the second independent variable plus a hat. So applying this to our example, we would have military spending hat equals 335.40 times GNP minus 567,163.63 times conflict plus 576,886.56. After you have written out your equation, you need to interpret the significance test for the coefficients b hat. In this process, you examine each coefficient separately. Recall that when we interpret the b hat, we want to know if it is different from 0. If b hat is not different from 0, there's no relationship between our independent and dependent variable. As the independent variable changes, the dependent variable stays the same. If b hat is positively different from 0, as the independent variable increases, the dependent variable increases. If b hat is negatively different from 0, as the independent variable increases, the dependent variable decreases. So to show you how to interpret the significance test for b hat, I will use the multiple regression analysis from earlier in the lecture. Recall that our regression equation was military spending hat equals 335.40 times GNP minus 567,163.63 times conflict plus 576,886.56. So we want to know if 335.40 is different from 0, and we want to know if negative 567,163.63 is different from 0. First, you should look at the sign of b hat for the first independent variable. Recall that these rows tell us the statistics associated with b hat for each independent variable. The b cells here tell us what the b hat is. If it is not in the expected direction, then b hat is not significant and is indistinguishable from 0. So let's say you expected the independent variable to have a positive effect on the dependent variable, but b hat was negative. Then your b hat is automatically insignificant. You do not have support for your argument. You cannot make any conclusions about the effect of the independent variable on the dependent variable. If your b hat is in the right direction, then move on to the next steps. Okay, so the next step is to look at the results of the significance test for b hat and SPSS. This last column here, sig, tells you the sig value for each b hat. If the sig value is less than 0.002, then the coefficient is significant and different from 0 at the 0.001 level. If not, move on to the next step. If the sig value is less than 0.02, then the coefficient is significant and different from 0 at the 0.01 level. If not, move on to the next step. If the sig value is less than 0.10, then the coefficient is significant and different from 0 at the 0.05 level. In all of these cases, you have support for your argument. The only difference between these three levels of significance is that if your significance tests meet these criteria, then your results are significant at the 99.9% level. If your significance tests meet these criteria, then the results will be significant at the 99% level. If your significance tests meet these criteria, then your significance test is significant at the 95% level. Now moving on. Let's say your sig value is greater than 0.10. That means your coefficient is not significant and is indistinguishable from 0. You do not have support for your hypothesis. An important note before I move on, anytime you see a sig value of 0.000, that is less than 0.002, so you have significance at the 0.001 level. So, if the coefficient is not significant, as in the sig value is greater than 0.10, then you do not have support for your hypothesis. You cannot make any conclusions about the effect of the independent variable on the dependent variable. If the coefficient is significant, indicate which level it is significant at. Indicate if the coefficient has a positive or negative effect on the dependent variable. If it has a positive effect, state all else equal. As the independent variable increases, the dependent variable increases. If it has a negative effect, state all else equal. As the independent variable increases, the dependent variable decreases. So applying this to our regression example, we expected GNP to have a positive effect on military spending. The b hat was positive, so we moved on to look at the sig value. The sig value is less than 0.002, so the coefficient b hat is significant at the 0.001 level. We can state that all else equal, as GNP increases, military spending increases. Now moving on to conflict. We expect conflict to have a positive effect on military spending. Yet the sign of b hat for conflict is negative, so the coefficient b hat is not significant. It is indistinguishable from 0, so we do not have support for our hypothesis. We cannot make any conclusions about the effect of the independent variable on the dependent variable. Now moving on to interpreting the constant a hat. Recall that a hat is also the y-intercept. In this equation it is 576,886.56. Interpreting a hat in a multiple regression is similar to interpreting it in a bivariate regression. We do not have an expectation about whether a hat is positively or negatively different from 0, so we just assess whether it is positively or negatively different from 0. So to determine whether a hat is different from 0, we look at the sig value here for a hat. Then we compare the sig values to these rules. Note that these rules are different from the rules for determining if b hat is significant. If the sig value is less than 0.001, then the constant is significant and different from 0 at the 0.001 level. If not, move on to the next step. If the sig value is less than 0.01, then the constant is significant and different from 0 at the 0.01 level. If not, move on to the next step. If the sig value is less than 0.05, then the constant is significant and different from 0 at the 0.05 level. If not, then the constant is not significant and is indistinguishable from 0. Also note that anytime you see a sig value of 0.000, then it is less than 0.001, and the significance is at the 0.001 level. Now, if the significance value is greater than 0.05, it is not significant. If this is the case, we would say the constant is not significantly different from 0. If the significance value was less than 0.05, then we would say it was significant. We would note what level of significance it was at and note whether it was positive or negative. So applying this to our example, the sig value for the constant was not less than 0.05, so the constant is insignificant. It is not different from 0.